Okay, in this video, I will explain to you on to how to solve this problem to find I phi. Okay, let's write that. We need to find I phi, which is the current that passed through this 5 ohm resistor and also the power dissipated by it. Okay, I think I will use not voltage method here. Let's see what can we get from here. Not voltage method. Okay, and these steps, the first step is to label all the nodes and also extract all the information available. Label all the nodes. How to do that? Let's see what can we get from here. Okay, in the bottommost node, I usually set that as our reference node. So this is our reference node or our ground. So what does that mean? That means that the voltage here will be 0. Good. And then what can we do from here? We can get this one here is 20 volt. Why? Because this is a voltage source. So that is 20 volt here. This is connected to the ground, so I will have 20 volt from the ground. And also similar things, because this is a dependent voltage source, the value is 8 I phi. So I will have 8 I phi here. So I have 8 I phi. Good. And now we have another unknown nodes, which is this one and this one here. Okay, let's name this node here as node Px, and then this node here as node Py. So the name is X and Y, but we need to know the voltage, so I name it Vx and Py, right? And I think we have extracted all the informations and also label all the nodes. Let's move on to the second step, which is assume the current's direction. Okay, assume the current's direction for each branch. Let's do exactly that. So we'll have here, I assume this will goes to the right. And then here I will assume this will go down. And here I also assume that it goes down. For this one, we already given that I phi is going to the right, so I just follow it. And then here we have the last one. I assume this one is going to the right. You can assume in other direction as long as you are consistent during the solving of the problem. But this is my convention. I usually use going to the right for the horizontal component and going to down for vertical component. And then what can we do from here? Let's do all. Let's do KCL. KCL for each nodes, each non-reference node, and also unknown node. So we need to do it at Px here, and then at Py. Let's do exactly that. Let's do the first KCL. Maybe let's separate the steps here and the calculation. Okay, let's do KCL here at node Px. KCL at node Px. KCL at node Px. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Good. And here, the only current that goes in is this one here, but we don't know the current yet, but we can use Ohm's law to calculate that, right? How to do that? Let's see here. The current comes from this 20 volt node, so I will have to write it 20, and then the current goes to this Vx node, so I will have minus Vx. Good, but this is voltage. We need current. How to get current from the voltage? We divide it by the resistance between them. So I will have to divide it by 2 ohm. Good. And then I think that's all for the current that goes in. Now we have to calculate the current that goes out. And here we will have two currents, 1 and to here. Okay, let's see that. So we will have Vx here as the origin of the current. So we will have Vx here. And then the current goes to the reference node, or the voltage there will be 0. So minus 0. And then here is voltage. So we need to divide it by the resistance between them to get current. So I'll have 20 there. And then this one here, we can play the same game. The current comes from Vx. And then the current comes to Vy. So I will have minus Vy. And then that is voltage. We need to divide by the resistance between them. So I will have, this one will be 5. Okay. So I need to get rid of all this denominator here. Maybe I can multiply all by 20. Why? Because this will be cancelled into some integers, right? So 2 and 20 will cancel into 10. So we will have 200 minus 10 Vx. Good. And then what else? 20 and 20 will cancel each other. So I will have Vx here, because Vx minus 0 is just Vx. So we'll have Vx, and then 5 and 20 will cancel into 4. So we multiply the numerator by 4. So I have 4 Vx, and then minus 4 Vy. Good. Now let's do simple arithmetics here. Vx plus 4. Vx, that will be 5 Vx, and then plus 10, that will be 15 Vx. So we'll have 15 Vx. And then what else can we get? We have minus 4 Vy. Minus 4 Vy. And all of that will equal to 200, right? 200. Okay, let's save this as equation number 1. Good. But then we have two variables. We still need to find out one more equation, which can we get from KCL at node Vy. Okay, maybe let's save the first equation first. Okay, now we got the first equation here. I save it here. And let's see what can we get from this node here. We need to do another KCL, but this time at node Vy. Again, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Good. Okay, the only current that goes in is that one. But then that one will be Vx, where the current comes from, and then minus where the current goes to, Vy, divided by the resistance between them to get current. So I will have 5. Good. And I think that's all for the current that goes in. Now let's move on to the current that goes out. I will have Vy here as the current comes from Vy. And then it goes to the reference node. And the voltage there will be 0. So I need to divide it by the resistance between them, which is 10. Good. And then let's move on again. So I will have plus this current here. So I will have Vy, where the current comes from, and then minus this one here, 8I5. Good, and then it will be divided by the resistance between them, which is 2. Okay, maybe let's multiply this by 10. Why? To get rid of all the denominator. Okay, so I will have 2Vx minus 2Vy, and then this will equal to 10 and 10 will cancel each other, so I will have Vy here, and then 2 and 10 will cancel into 5, so I will have plus 5 Vy, and then minus 5 multiplied by 8, that will be 40 I5. However, this I5 is a problem here, but we can use Ohm's law to calculate that, right? So let's take this node here. What is I5? I5 is this current here, right? And so we can also use similar game. So we'll have the current comes from Vx. So I have Vx, and then the current goes to Vy. So I have minus Vy. and then it's divided by the resistance between them, which is 5 ohm. So I will have 5 here. So we can replace this I5 here by this value. So let's do exactly that. Replace this I5 by this value here. So we will have Vx minus Vy divided by 5. Good. 5 and 40 will cancel into 8, right? And let's do some arithmetic here. So I'll have 2Vx minus 2Vy. And then this one, Vy plus 5Vy, that will be 6Vy, right? And then let's distribute this minus 8 to the bracket. So I will have minus 8Vx and then plus 8Vy. So I'll have plus 8Vy. Okay, why is my plus so bad? That will be plus like that. Okay, so now we will have, let's move this Vx to the left hand side. So I will have 10Vx. And then we'll have minus 2 minus 6. That will be minus 8. And then minus 8 and minus 8. So I will have minus 16 of Vy. And that will equal to 0. Or we can divide this, I think. So we will have 5Vx minus 8Vy, right? And all of that will equal to 0. And let's save this as equation number 2. So now we have equation number 1 and equation number 2. We have two variables, and this is a linear system equation. I think we can solve that, right? Let's do exactly that. Okay, so far we get equation number 1 from KCL in Vx, and then equation number 2 from KCL at Vy. And now we have Vx and Vy to be solved here, which is exactly the fourth step here, which is solve the linear equation. Solve linear equation. And how to do that? You can use Cramer's method or substitution and elimination, which is I will do here. So we will have this one, and I want to eliminate this Vy first. So I multiply the first one by 2, because this will resulting in 8, right? And I will multiply this by 1. Then we will have this one is equal to 30 Vx minus 8 Vy. And that will equal to 400. And then this one is still there, so I'll have 5Vx minus 8Vy, and that will equal to 0. Okay, I can subtract this, so I'll have 25Vx is equal to 400. Then what is Vx? Vx is 400 divided by 25. That will be 16. And the unit, I think that will be volt, right? Because this is volt and ohm. So this should be in volt. So here is one of the most important value. Vx is 16. Okay, now let's plug this 16 into equation number 2. So we'll have 5 multiplied by 16. And then minus 8 of Vy is equal to 0. 5 multiplied by 16 is 80, and that will equal to 8 Vy. Okay, we can isolate Vy and dividing both sides by 8. So I will have that will equal to 10 volt. Good, we now have Vx and Vy. So our Vx is 16 volt, our Vy is 10 volt. But then the question is not asking us about Vx and Vy, but I5 and the power dissipated by this resistance. So the last thing that we need to do is to answer the question. Okay, let's do exactly that. Okay, let's clean up this first. Okay, the question is asking us for I5. Okay, what is I5? I phi is this current here, and that current is Px, where the current comes from, minus Py, where the current goes to, divided by the resistance between them, which is 5. Okay, we can just plug that in. So I will have that will be 16, as Vx is 16, and then Vy is 10, so I'll have minus 10, and then divided by the resistance between them, which is 5. So I will have 6 over 5. And so I will have I phi, 6 over 5 is just 1.2. The unit here is in ampere. And then what is the power dissipated by this resistor there? And we need to find out the P of 5 ohm. We can just use the formula I squared multiplied by the resistance, right? So I will have I phi, as the current that passed through it is only I phi, squared, and that multiplied by the resistance between them, which is 5. So I will have 1.2 squared multiplied by 5. And I think I just use calculator for that. Let's do exactly that. So I will have 1.2 squared multiplied by 5. And that will be 7.2. So I will have the power dissipated by 5 ohm resistor. That will be 7.2 watt. And I think that is the final answer for this question. Okay, hopefully I did not make any mistakes during this calculation. It's very long calculation, but I think that's good enough. Thank you for watching. See you in the next video. Bye bye.